Hello, in this video I want to talk about how to find the inverse of a matrix. Before we talk about inverses, we need to talk about the identity. You may recall from your test, let's say we have a matrix, 1, -1, 3, 4. And I multiply it by 1, 0, 0, 1. I will get 1 times 1 is 1, and 0, I get a 1 here. 3 and a 0, I get a 3. Next column, a 0 and a -1, a 0 and a 4. Notice these are the same. And similarly, if I do it the other direction, I will also get the same matrix back. 1 times 1 and a 0, 0, 3, -1, 0, 0, 4. So this matrix is called the identity matrix. A 2 by 2 identity matrix. Any identity matrix is going to be square. This is the 2 by 2. You can have a 3 by 3, 4 by 4, 5 by 5, etc. We call it the identity because this matrix times anything of the right size will give you the same matrix back. Just like 1 is our multiplicative identity and 0 is identity, and 0 is our additive identity. Is that, I don't know what I spelled there. I can't spell ID. Let's think about multiplication. If you wanted to say solve the equation 2 times a 2 times x is equal to 3, you would divide both sides by 2. What you're actually doing when you divide both sides by 2 is you are multiplying both sides by the multiplicative inverse of 2, because 1/2 times 2 gives you a 1, 3 times 1/2 gives you a gross fraction. So I have x is equal to 3/2. We want to be able to do the same thing with matrices. Let's see how we can do that. Let's go back. What was the matrix? That just doesn't matter. Let's say I have the matrix 3, 1, 2, 1. And I want to find a matrix, call it A, B, C, D, such that I will get 1, 0, 0, 1. So what does this do? If I multiply these together, I get 3A plus C, and then I get 2A plus C. Over here, I'll get 3B plus D, and then I get 2B plus D. And that has to equal 1, 0, 0, 1. So look at what we've got here. Let's just look at this first column. They're all A's and C's. There are only 2 variables, and there's only 2 equations. I have 3A plus C and 2A plus C. This has to equal a 1 and a 0. So I would solve that the way I solve equations. I would have a 3, a 1, a 2, a 1, and a 1, 0. And I would put that in row-reduced echelon form. But now wait, before I do that, let's look at this other set of equations. I have 3B plus D, that will equal 0, and I'll have 2B plus D, that will have to equal a 1. So if I were to set that up, I would get a 3, a 1, a 2, a 1. The augmented matrix, I get a 0 and a 1, and I would put that in row-reduced echelon form. But notice, to go through the steps to put this in row-reduced echelon form and this in row-reduced echelon form, I'm going through all the same steps because I'm going to get a pivot here and here, hopefully. If the inverse exists, I'll get a pivot here and here. I'm going to do the same crap both times. No sense in doing it twice. We're going to do it at the same time. So let's set this up as, let's see, I have a 3, a 1, 2, 1. The first set of equations spit out a 0, 1, and a 0. And the second one spit out threw up, a 0 and a 1. And I'll have to put this in row reduced echelon form. Well, now notice that's the identity. And that's basically the way you're going to find the inverse. If you want, in general, if you want to find the inverse of A, any matrix, square matrix, you put the identity of the correct size here. You'll put this in row reduced echelon form. If the identity exists, you'll get the, if the inverse of A exists, you'll get the identity here, and A inverse pops up here. So let me do this. Let's see. I need to do this row minus that row. So I'll have 1, 0, 1, negative 1. Can leave this row alone. Board organization sucks. I'm going to say row 2 minus 2 times row 1. So that gives me a 0. 1 minus 0 is 1. 0 minus 1. Oh, that's kind of nice. 0 minus negative 0 minus 2 is negative 2. 1 minus negative 2 is a positive is a 3. Hopefully I did that right. So my A inverse in this case, or the inverse of 3, 1, 2, 1 inverse is 1, negative 1, negative 2, 3. Okay. Well, let's check it. When I multiply these together, I should get the identity matrix back. Just like before when we got 2 times 1/2 gives us 1, or 2 plus a negative 2 gives me 0. Here I have matrix and its inverse should give me the identity matrix. 3 minus 2 gives me a 1. So far so good. 2 minus 2 gives me a 0. Negative 3 and a positive 3 give me a 0. Negative 2 and a 3 gives me a 1. Yay, so I found it. And I should check the other direction, but I want to make this video shorter than that. So in general, if we want to find, as I said, if we want to find the inverse of a matrix, we put the identity next to it and then put it in row reduced echelon form, and the inverse will end up over here. If we can't put it in row reduced echelon form, if we don't have enough pivots, then that means that your matrix wasn't invertible. And that's how you find the inverse of a matrix.